First, we're going to find the critical numbers. And remember, the critical numbers are when the first derivative of the function equals 0 or is undefined, and that the critical numbers are x values. So we're going to find the x values where this is true. So we're looking for x's. So the first thing we have to do is take the derivative. So f prime of x is 3x squared plus 6x. And then we're going to see where it is 0. This is a nice polynomial, so there's no place it's undefined, so we don't have to worry about that. If you do have a rational function, which means something divided by 0, that is anything that makes the denominator 0 will give you an undefined value, and the other video I made explains that a little better. But in this one, we're just going to find the critical numbers of a normal polynomial. So we're going to find where this function equals 0. So 3x squared plus 6x. To do this, we're going to factor out a 3x, leaving x plus 2. And that means our possible critical numbers are going to be when x is 0 or negative 2. So these are our critical numbers. Next, we're going to find the absolute maximum and absolute minimum values. And these are y values. So we're going to test them not only at the critical numbers, but also at the endpoints. So we find max and mins at critical numbers and at endpoints. So we have to test all of those. And since we're looking for y values, that means we take these x values, because these are x values. And if you notice, these are what? Those are x values. So these are all x values. So we're going to find. And we want to know what the maximum of the original function is. The derivative here is just a tool we use to find the maximum value of the original function, right? So let's plug it in. So we have the original function. We're going to do f of 0 and f of negative 2, because those are critical numbers. And we're also going to find the endpoints. So it's f of negative 3 and f of 1. So we're going to plug all those in. F of 0 is 0. F of negative 2 is negative 2 cubed plus 3 times negative 2 squared, and that gives us negative 8 plus 12, which is 4. And negative 3 is negative 3 cubed plus 3 times negative 3 squared, which gives us negative 27. Oh, look at that. Plus 27, which is 0. And then f of 1 gives us 1 cubed plus 3 times 1 squared. And that gives us 1 plus 3, which is also 4. So in the function, since we've taken x values and plugged them into the function, the ordered pairs are going to look like this. 0, 0, negative 2, 4, negative 3, 0, and 1, 4. So these are the x values, and these are the y values of the function. So as we saw, especially on a closed interval, the extreme value theorem guarantees a maximum and a minimum value. And we know that maximum and minimum values can only happen at critical numbers and endpoints. So right now, what is the maximum value? So we're going to look at 0, 4, 0, and 4. Obviously, the maximum value is 4. And yes, it can occur twice. It doesn't matter how many times it occurs. We just know that between negative 3 and 1, the maximum value that this function attains is 4, and the minimum is 0. So the absolute maximum is going to be y equals 4, and the absolute minimum is y equals 0. Now we're going to look at that function and see what it looks like. So here's the function with no endpoints. This is just the normal function. So on this function, we have a relative max and a relative min, but there's no absolute max and absolute min because it goes on and on and on, goes on forever. But notice, when we have endpoints, which means when we cut this off, then we are going to have an absolute max and an absolute min. In fact, remember 4 is the y value of our absolute max, happens in 2 places, and where is that? Like we found before, it's at negative 2 and it's at 1. And our absolute min is going to happen here and here, which, what is the value of the absolute min? The value of the absolute min was 0, and that happened where? That happened at -3 and 0. So we have the absolute max, right, was y equals 4, and the absolute min was y equals 0. And that's it. Have a great night.